Okay guys, we're going to look at reciprocal functions now. That is all the functions related to y equals 1 on x. I'm going to talk about the key features and how to transform them. I'm going to talk really fast, so make sure you stop the video and rewind and watch it a number of times if you need to. First of all, let's talk about what this word reciprocal means. So reciprocal of 3 is 1/3. Reciprocal of 5 is 1/5. Reciprocal of 6/7 is 7/6. Reciprocal that can be -2. So reciprocal of -2/3 is -3/2. Basically, reciprocal of x is 1 on x. So what's a reciprocal function? Well, it's y equals 1 on x. In this video, I'm normally going to write it f of x equals 1 on x to get us thinking about input. X is the input and 1 on x is the output. Whatever you put in for x into here gives you an output, a y value of this, of 1 on x. All right, so let's see what that looks like as a graph. Let's do this by plotting a table of values. Well, not exactly a table yet, but let's go through a few main values. If I put an input of 1, the output will be 1. So 1, 1 is on the graph. If I input -1, 1 over -1 is -1. So -1, -1 is on the graph. Let's try 2. So x equals 2, y equals 1/2. Let's put -2. 1 over -2 is -1/2, so that's on the graph there. Because we want to save time, let's do the opposite, because the reciprocal of the reciprocal is the original number. So reciprocal of 1/2 equals 2. So 1/2, 2 is on the graph, and -y is the same thing. Now I think we can all see logically, just to save a bit of time, if I've done this with 2, I can do it with 3 as well. And I could do it with 4, 5, 6, 7, all the numbers, right? So here's 3 1/3, here's 1/3 3. Here's -1/3 -3, and this is -3 -1/3. Okay, and you can imagine this will be 4 1/4, 5 1/5, 6 1/6, 7 1/7, 8 1/8, etc. 100 1/100th, a million 1/1,000,000th. So as the x values just keep getting bigger and bigger, the y values will get smaller and smaller fractions. And the converse of that will be happening over here. As x gets closer and closer to 0, as these fractions get smaller and smaller, the y values will be getting bigger and bigger. And same here in the negative direction, and the same idea here in the negative x direction. So it'll end up looking like this. Okay, the interesting thing to talk about here is this, undefined. All right, we can't divide by 0. 1 divided by 0 is undefined. For all of you who've been putting 1 divided by 0 equals infinity, this is showing you that that's wrong, right? Because at 0, it's positive infinity, it's also negative infinity. But infinity, we don't know what it is anyway, so it's undefined. So 0 can be anything positive and negative, undefined, too big to define. It doesn't work. Okay, so we can't put anything there. So we end up with a graph like this, where the curve keeps getting closer and closer to the axes and never crossing. Closer and closer to the axes and never crossing. You can actually see that if I've zoomed out now, and you can see that, well, you can't really see, but you can imagine here that it's getting closer and closer but not crossing the axis. It's really hugging the axis. So let's talk about the features of this graph. The shape of this graph is called hyperbola. It's a hyperbola. It's a type of conic section related to a parabola. You'll hopefully understand that relationship later on when you study conic sections later in your math journey. The domain of this function is everything, all real numbers except 0. You can put any value in here for x except 0 and you'll get a result. But if you put in 0, you'll get it undefined. So you can see, just by doing a little transformation in your head, you can see that the same thing will happen for y. There is no way you can get a 0 here. No number you can put in for x that will give you y equals 0. Or if you rearrange the function, you'll say x equals 1 on y. Y can't be 0 either. Okay? Just to reiterate what I've just said, there's no intercepts. Okay? It doesn't cross the x or y axis. So let's talk a bit more about these lines that the curve doesn't cross, and they're called asymptotes. And we have the y-axis, which is called x equals 0, and the x-axis, which is called y equals 0, are asymptotes. Asymptote, not asymptote, and it comes from 3 Greek words, or 3 Greek parts of words. Just like atheist and amoral and asexual and asymptomatic, means not. Right? Atheists believe there is not a God. Asymptomatic means you don't have symptoms. You do not have symptoms. So A is not. The sim part here means the same thing it means in sympathy, symphony, symmetrical, symbiotic, right? Symphony you hear with, or hear together. Sympathy you feel together. Symmetrical you measure together. Symbiotic you live together. This is together. And tote means to fall. There's not an English equivalent. So asymptote means not fall together. It's the curve does not fall together with the line. It approaches the line, but it doesn't intersect. Okay, so the curve is the curve. The asymptote is the line that the curve approaches. And in our example, in this example here, the asymptotes are a vertical asymptote, which is the y-axis, which is x equals 0, and a horizontal asymptote, which is x-axis, y equals 0. Okay, so that is the main reciprocal function, y equals 1 on x. We're going to call that the parent function. And every other reciprocal function is a transform function, comes from that and is related to that and looks like that. It shares the characteristics of that. It's a genetic mutation. And here the A, H, and K, you might recognize that from your parabolas and vertex form. They do the same job. These 3 parameters do the same job they do with parabolas. And we'll see that now. So here's our original parent function, all right, our starting function, y equals 1 on x, with the horizontal and vertical asymptotes going through 1, 1 and -1, -1. Y equals 2 on x has the same asymptotes. Instead of going through 1, 1, it goes through 1, 2, and 2, 1. And here, -2, -1, -1, -2. Interesting. This is 4 on x, goes through 1, 4, and 4, -1, and -4, -1, and -1, -4. Oh, and by the way, look, it goes through 2, 2. I'll talk about that in a minute. Y equals 9 on x. You can't see it here, but it'll go through 1, 9, and 9, 1, etc. And look at that, it goes through 3, 3, and -3, -3. Why is that? Well, imagine this line. This line, actually it's a line of symmetry for our functions here. Yes, they're symmetrical this way, by the way. I should have mentioned that before. They reflect this way, but they also reflect on this line. And this is y equals x. And when y equals x meets y equals a on x, then x equals a on x. So x squared equals a. So a equals plus or minus square root of a. So here, this point is 1, 1. X equals 1. Y equals square root of 1. This is root 2, root 2. This is 2, 2. This is 3, 3. This is -3, -3, -2, -2, -1, -1. Okay? So that helps you know how to draw your graphs. Okay, let's talk about H. no, let's talk about the other thing that A does. You can see here with y equals 1 on x, you got the red graph. Y equals negative 1 on x is this black graph here, and you can see just like parabolas, it's been reflected in the x-axis. It's been flipped vertically. And you can see that if we talk about the quadrants, y equals 1 on x is in quadrant 1 on 3. Y equals negative 1 on x is in quadrants 2 and 4. So if you have a negative value for A, you'll be talking about these two quadrants. If it's positive, it's these two quadrants, whatever the value of A is. Okay, now let's talk about H. So we can see here, y equals 1 on x minus 2. I've shifted the whole graph to the right. Now I've got a new vertical asymptote at x equals 2. Remember, 2 minus 2 will be 0, so that's what will make this undefined when the denominator here is 0. So you've got a vertical asymptote wherever this is undefined. Same thing with y equals 1 on x plus 3, so the vertical asymptote is x equals negative 3. Okay, let's talk about the k. Alright, this time we've got the whole graph here of y equals 1 on x, and we moved every point up by 2. So now we've got a new horizontal asymptote, y equals 2. And same for moving it down. Here we've moved everything down by 1, so we've got a new horizontal asymptote, y equals negative 1, and there's the negative 1. Okay, so that's it. So now let's see if we can apply this, and I'm going to go super fast through these 4 examples. Okay, so here we've got a vertical asymptote at x equals negative 3, so h is going to be negative 3. Got a horizontal asymptote at y equals 2, so k is going to be 2. If we go from the vertex here, from the crossover point, we go up 1, across 1, or back 1, down 1. So that's 1 we've moved, so A is going to be 1. Okay, next one. We've got a vertical asymptote here of x equals 1, so h is going to be 1. We've got a horizontal asymptote of y equals negative 2, so k is going to be negative 2. And look, from this crossover point here, this vertex, we go up 1, across 1, or across 1, down 1 to get to our graph, so it's going to be 1. But hang on, we're in quadrants 2 and 4 with respect to our asymptotes here, so it's going to be negative 1. A is negative 1. Okay, 2 more examples. This one, let's go vertical first. This is x equals 3, so h is 3. Horizontal asymptote, y equals 2, so k is 2. And this time, from this vertex point here, we'll go 2 and 1 to get to the graph. 2 and 1, 2 and 1, 2 and 1. And we're in the negative sections, so this is negative 2 on the top. Okay, last one. Here we've got vertical asymptote is x equals 2. Horizontal asymptote, y equals negative 1. So this is 2, this is negative 1. And then A will be, look, you count from there, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. So it's going to be 3. And it's in the positive section, so it's going to be positive 3. Okay, just to finish off, I'd like to encourage you to investigate a relationship here between y equals x and y equals 1 on x, y equals x plus 3, and y equals 1 on x plus 3. Look at how the x-intercept is related to the asymptote. Look at how the y-intercept is related to the y-intercept. Things like that. You can investigate yourself that relationship. That will help your understanding. All right, go practice now.